This question is from optics. Okay, it's given that a beam of polychromatic light. Polychromatic means it contains different wavelengths. Monochromatic alla, polychromatic. It passes through a thin prism of angle 60 degree. The refractive index of the material of the prism varies with wavelength lambda as n lambda is. Refractive index is a variable. It's varying with the wavelength. Where alpha is given, beta is given. Lambda minimum is the wavelength at which angle of minimum deviation is smallest. Okay. Lambda minimum is the wavelength at which angle of minimum deviation is smallest. See, angle of minimum deviation itself is smallest at a particular angle. What is the correct value of dm at delta, that minimum? See, we know that the angle of minimum deviation, we write it as d. Angle of minimum deviation d എന്ന് പറയുന്നത് അത് for thin prism it is mu minus 1 into a ആണ്. And mu is given. ഇപ്പം നമുക്ക് ഇവിടെ d എഴുതാം. d മ്യൂവിൻ്റെ വാല്യൂ എത്രയാണ് തന്നിരിക്കുന്നത്? It is given as I think it's alpha lambda plus beta lambda square minus 1 into the angle of the prism. It's a. You can put the value later, okay. Now we want minimum deviation to be minimum. Minimum deviation must be minimum. So I'm writing wavelength is the variable. So dd divided by d lambda. That's for the condition for minimum. Equal to, with respect to lambda, this will give you alpha plus beta by lambda square. Beta by lambda square will give you minus 2 beta by lambda cube. Rest are constants. Okay. And for minimum condition, this should be equal to 0. From this, I'll get 2 beta by lambda cube equal to alpha, or lambda cube equal to 2 beta by alpha. Now we have the value of beta and alpha. So lambda cube equal to 2 into beta is 0.096 divided by alpha is 3. Lambda cube equal to 3 goes here, 32 into 2. 0.064 is lambda cube. Take the cube root of 64 is 4. This will give you 0.4 micrometer because the values of both beta and alpha are in micrometer ranges. So this is the wavelength, micrometer. Now we will calculate the refractive index n at this particular value. N is equal to alpha into lambda. Alpha is 3 into 0.4 plus beta is 0.096 divided by lambda square, 0.4 square. Since the units are in micrometer, no need to convert them. This will give you 1.2 plus 0.096 divided by 0.16. That is 6 times, right? So that is 1.2 plus 0.6. This will give you 1.8. So the refractive index is 1.8. Now what is d minimum? D equal to mu minus 1 into lambda. I wrote it as mu minus 1, doesn't matter, mu or n. That is 1.8 minus 1 into angle is 6 degree. 1.8. 0.8 into 6 will give you 4.8 degree. Answer option B, 4.8 degree. This is pretty forward, just to do differentiation. I just got stuck in this wavelength at which angle of minimum deviation is smallest. There is so many minimums in that. അല്ലാതെ ഒരു കുഴപ്പമൊന്നുമില്ല. ഓക്കെ, ഞാനെല്ലാം ഇങ്ങനെ കുഴപ്പമില്ല എന്ന് പറയുമ്പോഴേ നിങ്ങൾക്ക് അങ്ങനെ തോന്നണമെന്നൊന്നുമില്ല കേട്ടോ.